All right, guys, here we are for lesson 2. As I said, we are going to move into electrical safety. I said in the last video that you can go to nfpa.org and you can download the link, NFPA link. Let's go there so you guys can see. I have it saved. But you can go to this website and search up here, NFPA link. And we can find here in codes and standards, there it is right there. It's up at the top. NFPA link. You can try a 14-day trial, but that's what we're going to use to go through our electrical safety section. The TDLR wants us to use the NFPA 70E. The normal code book is NFPA 70, and NFPA 70E is safety, electrical safety. You can see electrical safety in the workplace. So we're going to use this as our guide to go through. We'll talk about electrical stories that might have happened. We'll try and break this down so you guys have an understanding of what this book is. Perhaps you've never even seen it. But OSHA has, or sorry, the National Fire Protection Association has come out with this to give us ways to stay safe while we're working. So we'll start off with the origins. This edition of NFPA 70E standard for electrical safety in the workplace was prepared by the Technical Committee on Electrical Safety in the Workplace and released by the Correlating Committee on National Electric Code. It was issued by the Standards Council on June 1st, 2020, with an effective date of June 21st, 2020, and supersedes all previous editions. This edition of NFPA 70E was approved as an American national standard on June 21st, 2020. This, what you are looking at, is the new 2021, as you can see it up here, NFPA 70E. I didn't know that it came out yet, but I went on here last night and they had come out with it. So that's what we're going to go over. The foreword, the Standards Council of the National Fire Protection Association announced the formal appointment of a new Electrical Standards Development Committee on January 7, 1976. The Committee on Electrical Safety Requirements for Employee Workplaces reported to the association through the Technical Correlating Committee on National Electric Code. The committee was formed to assist OSHA in preparing an electrical safety standard that would serve OSHA's needs and that could be expeditiously promulgated through the provisions of Section 6 of the Occupational Safety and Health Act. OSHA found that in attempting to utilize the latest edition of the NEC, it was confronted with the following problems. So what they're telling us here is that this book was created because the National Electric Code was not sufficient to provide electrical safety in the workplace. As you guys will see when we get to the National Electric Code section, the National Electric Code is a minimum safety standard for installing, how we do it, wiring methods, grounding, bonding, all of that stuff is in there. But that, what they're saying, was not sufficient to provide electrical safety in the workplace. So that's why this was created. Number one, OSHA could not adopt or modify a standard through procedures that provide for public notice, opportunity for public comment, and public hearings. The adoption of a new NEC edition by these procedures would require extensive effort and application of resources by OSHA and others. Going through the procedures might result in requirements substantially different from those of the NEC, thereby creating a conflict between the two standards. Number two, the NEC is intended for use primarily by those who design, install, and inspect electrical installations. Most of the NEC requirements are not electrical safety, related work practices, electrical system maintenance, or directly related to employee safety. However, OSHA electrical regulations, which address employers and employees in their workplaces, needed to consider and develop these safety areas. It became apparent that a need existed for a new standard tailored to fulfill OSHA's responsibilities that would still be fully consistent with the NEC. So you can see this is working in tandem with it. They could not use the NEC, the NFPA 70 as an electrical workplace standard, so they created this. This led to the concept of a new document that would extract suitable portions from the NEC and from other documents applicable to electrical safety. So you can see there, they do use the NEC as somewhat of a guide, as well as other, perhaps they use ASHRAE and IESNA and, all lighting and whatever other documents they use. Perhaps it's in here and will explain it to us, what they use specifically, but that's kind of how this whole thing came about. This concept offered and an offer of assistance was submitted in May 1975 to the Assistant Secretary of Labor of OSHA, who responded as follows. The concept, procedures, and scope of the effort discussed with my staff for preparing the subject standard appear to have a great merit, and an apparent need exists for this proposed consensus document, which OSHA could consider for promulgation under the provisions of Section 6B of the Act. OSHA does have an interest in this effort and believes the proposed standard would serve a useful purpose. With this positive encouragement from OSHA, the NFPA electrical section unanimously supported a recommendation that the NEC correlating committee examine the feasibility of developing a document for evaluating electrical safety in the workplace. With recommendations from the electrical section and correlating committee, the Standards Council authorized the establishment of a committee to carry out this examination. This committee would develop a standard for electrical installations that would be compatible with the OSHA requirements for employee safety in locations covered by the NEC. The standard was visualized as consisting of 4 major parts. Pay attention to this. Part 1, installation safety requirements. Part 2, safety related work practices. Part 3, safety related maintenance requirements. And Part 4, safety requirements for special equipment. It was not considered essential for all of the parts to be completed before the standard was published and made available. Each part was recognized as being an important aspect of electrical safety in the workplace, but the parts were sufficiently independent of each other to permit their separate publication. The first edition of NFPA 70E, Standards for Electrical Safety Requirements for Employee Workplaces, was published in 1979 and included only Part 1, Installation Safety Requirements. We're not going to read this whole thing. It goes into all the different publications and all of the different years, and we know they continually update. I believe that this one is also about every three years. Yep, the last one was 2018, and they just brought this one on in 2021. So that is kind of how the NFPA 70E came about. Now, the committee personnel. The National Electric Code itself is also broken down like this, and we'll go over it when we get over there. But the way it works is there is a committee that is over each section of the code. That committee oversees that section, and the way that it works is the public is allowed when they'll do an edit. So we just finished the one in 2021. They just released it to us. We can now read it. We can view it. This is the new standard that we as electricians have to go by. Employers have to go by this. When they start working on the next revision, each committee will look over their specific section that they are in charge of and make any changes or edits that they feel need to happen. And then what happens is they open that up to public opinion. So you, me, electricians, manufacturers, anybody can submit an actual, it's almost like a legal, you have to follow a specific parameter for it to actually be a response to how they changed the code. So they set it out, they let us all look at it, we can make comments on it, and then they go back and they review the comments on their specific section, and then the finalized publication comes out. Does that make sense? So here you can see you have all of these people who are a part of the committee on for this specific book. This is the Technical Committee on Electrical Safety in the Workplace. There should be more down here. Anyways, Correlating Committee on the National Electric Code. The chair, Lawrence S. Iyer, and then all of the people who make up actually editing this and creating it and making sure that it stays up to date based on current, new technologies come out, new safety has to be implemented. That's the way it works. Introduction. So now we get into Article 90, not to be confused with NEC Article 90. They both have an Article 90. They both start just like this, 90.1, purpose. You would be surprised as to how many people have never read Article 90 of either the code and especially NFPA 70E. Right here in 90.1, it tells us the purpose of why this book is here. The purpose of this standard is to provide a practical, safe working area for employees relative to the hazards arising from the use of electricity. I'm going to read that again. The purpose of this standard is to provide a practical, safe working area for employees relative to the hazards arising from the use of electricity. Makes perfect sense. Section 90.2, scope. A, what is covered in this standard? This standard addresses electrical safety-related work practices, safety-related maintenance requirements, and other administrative controls for employee workplaces that are necessary for the practical safeguarding of employees relative to the hazards associated with electrical energy during activities, things that we do, such as the installation, the removal, the inspection, the operation, the maintenance, and demolition of electric conductors, electric equipment, signaling and communications conductors and equipment, and raceways. So basically all of the installations that we do are covered under the way to work safely within those installations is by following their guidelines. This standard also includes safe work practices for employees performing other work activities that can expose them to electrical hazards, as well as safe work practices for the following. 1, installation of conductors and equipment that connect to the supply of electricity. Number 2, installations used by the electric utility, such as office buildings, warehouses, garages, machine shops, and recreational buildings that are not an integral part of a generating plant, substation, or control center. Right here, something I want to show you guys, informational note. This standard addresses safety of workers whose job responsibilities involve interaction with energized electrical equipment and systems with potential exposure to electrical hazards. Concepts in this standard are often adapted to other workers whose exposure to electrical hazards is unintentional or not recognized as part of their job responsibilities. The highest risk for injury from electrical hazards for other workers involve unintentional contact with overhead power lines and electrical shock from machines, tools, and appliances. The first note on that, this is an informational note. This is not something that you can quote to an inspector. This is not a code itself. You cannot go in here and say, well, that informational note says this, so therefore I can install this way. It is just an informational note, and it is there just to provide extra information to help you understand the section that we just read before. Does that make sense? The second note on that is right here. The highest risk for injury from electrical hazards for other workers involve unintentional contact with overhead power lines and electric shock from machines, tools, and appliances. This goes back to what we said in the last video. They know, and we know, that electricity is dangerous. Overhead lines and everything with inside of a building. That is why we are going over this. This is why the TDLR finds that this is very important for us to go over. So don't think that you're sitting here wasting your time. We're going to go through this, and you are gaining knowledge. You are going to gain some information. If not anything, at least that you're just exposed to this book and you know that it exists, so that if there is a situation that you run into where you don't know what to do, you don't know how to protect your guys, you don't know a certain procedure to follow, we can look here. They have done a very good job of trying to umbrella the entire electrical industry using the NEC, using other resources, umbrella the entire thing with a way that we can work safely. So this is a very good resource for us. B, A was what is covered in the code. B, what is not covered in the code. This is important as well. This standard does not cover safety-related work practices for the following. There is a very closely aligned statement like this in the NEC. You're going to see that when we get into it. What is covered and what is not covered. They want to be clear not only what they are covering, but what they are not covering. This standard does not cover safety-related work practices for the following: installation in ships, watercraft other than floating buildings, railway rolling stock, aircraft, or automotive vehicles other than mobile homes and recreational vehicles. It also does not cover installations of railways for generation, transformation, transmission, or distribution of power used exclusively for operation of rolling stock, or installations used exclusively for signaling and communication purposes. Number three, it does not cover installations of communications equipment under the exclusive control of communications utilities, AT&T, Cox, whoever you have, located outdoors or in building spaces used exclusively for such installations. The cable box you have outside your house, they are not covering that in this. This is not for electrical safety for low voltage cable work outside. This is key. This is another thing I want to point out before we get too far. You have got, when you go through the codes, both in NFPA 70E and in NEC, you have got to make sure that you pay attention to the wording. You need to become very legal. All of the terms in here, it can be very, anybody who's taken their journeyman license or their master's license understand it's the way that they word the code sometimes can be very difficult. But it's imperative that you spend the time, read it, and fully understand what is being said in each passage, each section. Number four, installations. It is under the exclusive control of an electric utility where such installations consist of service drops or service laterals and associated metering, or are located in legally established easements or right-of-ways designated by or recognized by public service commissions, utility commissions, or other regulatory agencies having jurisdiction for such installations, or are on the property owned or leased by the electric utility for the purpose of communications, metering, generation, control, transformation, transmission, or distribution of electrical energy, or are located by other written agreements either designated by or recognized by public service commissions, utility commissions, or other regulatory agencies having jurisdiction for such installations. These written agreements shall be limited to installations for the purpose of communications, metering, generation, control, transformation, transmission, or distribution of electrical energy where legally established easements of right-of-ways cannot be obtained. These installations shall be limited to federal lands, Native American reservations through the U.S. Department of the Interior Bureau of Indian Affairs, military bases, lands controlled by port authorities, and state agencies and departments, and lands owned by railways. Again, these are all areas that were not covered by NFPA 70E. 90.3, standard arrangement. This standard is divided into the introduction and 3 chapters as shown in figure 90.3. Chapter 1 applies generally. Chapter 2 addresses safety-related maintenance requirements, and Chapter 3 supplements or modifies Chapter 1 with safety requirements for special equipment. Again, Chapter 1 applies generally to all installations. Chapter 2 addresses safety-related maintenance requirements, specific to maintenance, and Chapter 3 supplements or modifies Chapter 1 with safety requirements for special equipment. So you're going to have in Chapter 1 your general overview, and you will see as we go through references to Chapter 3. Chapter 3 modifies those. It can enhance the safety in specific situations. Informative annexes are not part of the requirements of this standard, but are included for informational purposes only. So that's another thing. Excuse me, that's another thing that we have the informational notes that cannot be quoted that are there for informational purposes. And we also have the informative annexes. Both of those are not part of the requirements, but they are included for informational purposes only. All right, so here we see what we just read kind of broken down. So for you visual people out there, this is very helpful. Got your introduction, introductory and explanatory material, what we're going through, Article 90, Chapter 1, safety-related work practices, Chapter 2, safety-related maintenance requirements, Chapter 3, safety requirements for special equipment, and informative annexes. And you see here, Chapter 1 applies generally to electrical safety in the workplace. Chapter 2 addresses safety-related maintenance requirements. Chapter 3 modifies the general requirements of Chapter 1. And the informative annexes, informational material only, not mandatory. 90.4. Mandatory rules, permissive rules, and explanatory material. Here we're going to get a little deeper into how the code is laid out. Mandatory rules. A, mandatory rules of this standard are those that identify actions that are specifically required or prohibited and are characterized by the use of terms shall or shall not. We will see that as we get in. It will say you shall not do this. You shall do this. Those are mandatory. There's no exceptions to that. Permissive rules. B, permissive rules of this standard are those that identify actions that are allowed but not required, are normally used to describe options or alternative methods, and are characterized by the use of the term shall be permitted or shall not be required. C, explanatory material. Explanatory materials such as references to other standards outside of this code, references to related sections of this standard, or information related to a rule in this standard is included in this standard in the form of informational notes right here. Such notes are informational only and are not enforceable as requirements of this standard. Brackets containing section references to another NFPA document are for informational purposes only and are provided as a guide to indicate the source of the extracted text. These bracketed references immediately follow the extracted text. Right here, we see an informational note as an example. The format and language used in the standard following guidelines established by NFPA and published in the National Electric Code Style Manual. Copies of this manual can be obtained from NFPA. Again, nfpa.org. You can go there. You can get the link. I love it. It's fantastic. $10 a month. I spend more than that at McDonald's nowadays. D, informative annexes. These are non-mandatory information relative to the use of this standard is provided in informative annexes. Informative annexes are not part of the requirements of this standard, but are included, again, for informational purposes only. So, and the last section here in Article 90 is 90.5 formal interpretations. To promote uniformity of interpretation and application of the provisions of this standard, formal interpretation procedures have been established and are found in the regulations governing the development of NFPA standards. So what they're saying in that last section, formal interpretations. Let's say you're on a job and you don't understand a code, something, a safe work practice, something's going on, you don't know one way or the other what to do. So you come to NFPA 70E, you look that up, you find it, but you still kind of don't understand what it's saying. Well, what you can do is NFPA has a place where you can submit what they call a formal interpretation. And that question, it's a question asking, can you help me interpret this? Interpret this. Help me understand what this means more. That email, if you do it in the right place, you can't just shoot off an email to NFPA, info@nfpa70e.com or whatever. You can't do that. You have to actually go through a formal process. And that will actually go to one of the members of the committees that we were talking about earlier. And they will actually look it over, read, and help you understand, and they will respond to that in a formal response. So you can get, and that formal response can help you in the event, like when we get to the NEC portion, say you're there with an inspector, you differ on something. You can bring that and show that to the inspector. Now, whether or not the inspector listens or not, that's really up to him. I mean, he's the authority having jurisdiction, the AHJ. He's the one who has the final say, but it's worth a shot. And really, just for your own information, if you don't understand something and you want to learn it, you can send that into them and they will help. It's a fantastic resource to have. We go back. Now we get into chapter 1, safety-related work practices. Here we see the breakdown. We have Article 100, definitions, Article 105, application of safety-related work practices and procedures, Article 110, general requirements for electrical safety and safety-related work practices, Article 120, establishing an electrically safe work condition, Article 130, work involving electrical hazards. I keep reminding you of this, but the NEC has Article 100. It has some of the same article numbers. Do not, get them confused. Article 100 definitions is also Article 100 definitions in the NEC. Article 90 introduction is also Article 90 in the NEC introduction. So just make sure that you get it in your mind. These are two separate documents. One having to do specifically with safety, the other having to do with a minimum safety standard for our installations. All right, Article 100, definition, scope. You'll see at the beginning of every single article in both NFPA 70E and in NFPA 70, which is the NEC, scope. It lets us know what this article is about. This article contains only those definitions essential to the proper application of this standard. It is not intended to include commonly defined general terms or commonly defined technical terms from related codes and standards. In general, only those terms that are used in 2 or more articles are defined in Article 100. Other definitions are included in the article in which they are used, but may be referenced in Article 100. The definitions in this article shall apply wherever the terms are used throughout this standard. Accessible as applied to equipment. Definition: admitting close approach, not guarded by locked doors, elevation, or other effective means. Why is this important? Well, we'll see we have certain circumstances where you're not allowed to install a certain device in a place where it is not accessible, right? Well, what does accessible mean? That's up for interpretation. Well, what they're trying to do is limit that interpretation to this definition: admitting close approach, not guarded by locked doors, elevation, or other effective means. That's how all of these are. Approved, acceptable to the authority having jurisdiction. It is an approved standard. Arc flash hazard, a source of possible injury or damage to health associated with the release of energy caused by an electric arc. How many of you guys have seen videos of an arc flash? We've all seen them. I saw one video where the guy was standing in front of a piece of gear, super sad video, blew up 2,000 or 3,000 amp gear. The guy disappeared. Again, safety, safety, safety. That is the purpose of this. I mean, we've all watched the electrical fails videos where, you got the bird that flies into the power lines, or the cat that's up on the line, or whatever it is, transformers blowing up, power packs blowing up. That is why we're going through this, so that these things don't happen. No arc flash. We don't need any of that. Arc flash suit. I don't know how many of you guys have used one of these. Certain arc flash suits have different ratings depending on the voltage that you're using. A 120, 208 system has a different rated suit than a 277, 480 system, and higher, 12 kV, all those things. We have to make sure that when we are working on energized equipment, which should be a minimum, that we have to do that. Don't be lazy, find a breaker, shut it off. But in certain circumstances, we're working in live facilities, we're working in a scientific laboratory where they have live experiments going on, and they can't shut the power off to any of this stuff. We have to work, they have to work hot with the system energized. We have to then take the safety measures and make sure that we follow the proper steps to be safe in that situation. An arc rating. This is what I was talking about. You have to have a suit that is rated for whatever the arc rating is of that electrical system. The value attributed to materials that describes their performance to exposure to an electric arc discharge. The arc rating is expressed in cals per centimeter squared and is derived from the determined value of the arc thermal performance, ATPV, or energy of break open threshold, should a material system exhibit a break open response below the ATP value. ATPV. Arc rating is reported as either ATPV or EBT, whichever is the lower value. Again, we have some more informational notes here. We don't need to go into all of those. Attachment plug, a device that by insertion in a receptacle establishes a connection between the conductors of the attached flexible cord and the conductors connected permanently to the receptacle. AHJ, this is what I was talking about earlier, the authority having jurisdiction. This might be a city inspector, this might be a county, this might be a federal inspector. The military jobs, they all have different types. I was working on a high-rise, a military high-rise, and it was not a city inspector. It was actually pretty funny because the guy never had done a commercial building ever. So we really had the opportunity to take advantage of him if we wanted to, because he had no idea what he was looking at. We didn't. Again, it goes back to professionalism, and installing things according to how the NEC and how NFPA 70E tell us to. You can try and get away with things. It's going to come around and bite you at some point. So again, authority having jurisdiction is the organization, office, or individual responsible for enforcing the requirements of a code or standard, or for approving equipment, materials, and installation or a procedure. Informational note here, the phrase authority having jurisdiction, or its acronym AHJ, get that in your mind. AHJ, AHJ, they are the ones who have the authority. These are the guys and the women who you want to make friends with. You do not want them to be upset with you. They can make our lives very, very difficult by nitpicking minor things that they typically wouldn't. You know, one of the things that I strive to do in my electrical installations is to get it right the first time. Because you get an inspector out there and you have a bad installation, and it's not just that one inspection that he's going to be looking out for you. He's going to be looking at every single inspection that you ever have in the future. Foreman, general foreman, business owners, we all know this. It is not something that we do not want to get them on our bad side. So sometimes they'll come out and they'll have these pet peeves, you know, one little thing that they always want to focus on. At that job that I was at, the guy didn't want any of the MC sitting on top of the ducts. That was it. He didn't care about the strapping. I mean, as I was walking with the inspector, I noticed sections of MC that were 16 feet long that didn't have a strap on. And I'm sitting there fuming inside of myself because I'm walking with the inspector and my guys didn't follow proper, simple strap your MC. He looked right at it, turned around, went around the corner, found a piece of MC that was laying on top of the duct and called us on that one. So again, some inspectors, they call them triple threats. Some of them are, they look at electrical, mechanical, and plumbing. They look at all of them. So they're not specific to one trade. But still, we want to make sure we're installing in a proper manner. Automatic, performing a function without the necessity of human intervention. Balaclava, an arc-related head protective fabric, that protects the neck and head except for a small portion of the facial area. That's what we put on when I'm putting an arc flash suit on. Every single arc flash suit bag should have this fabric in it. You pull it over your head, then you put the hard hat with the mask over it, you put your suit on, and you go do your work. A barricade, a physical obstruction such as tapes, cones, or A-frame type wood or metal structures intended to provide a warning and to limit access. We've all seen these. You got them on roofs, 6 feet, 16 feet in some locations away from the edge. It could be cones, delineators. They could weld up some L metal and put some aircraft cable through it. There's tons of different ways that we have barricades. And it's simply there to provide a warning to us, to help us understand, hey, don't go in this area. Red tape, where I'm working, yellow tape is you can cross it. Red tape, do not go in. You're supposed to put a sign up, put your phone number on it. If that is your area, if you put red tape up, and then people are not allowed to walk into that space, they have to call that phone number and they have to get in touch with you and you have to give them the approval. I've seen guys kicked off of jobs because they crossed these sections that they're not allowed to go into. Don't do it. If you see a barricade, stay away from it. Barrier, a physical obstruction that is intended to prevent contact with equipment or energized electrical conductors and circuit parts. We have tons of these. Dead front covers, panel covers, transformer covers, all whatever it is, a simple 4S blank cover, right? It's trying to protect people from energized electrical conductors and circuit parts. Bonding, connected to established electrical continuity and and conductivity. Bonding conductor or jumper, a reliable conductor to ensure the required electrical conductivity between metal parts required to be electrically connected. Arc flash boundary, limited approach boundary, building, cabinet, circuit breaker, conductive, conductor bear. I'm not going to go through every single one of these. We're getting close to the end of this video. We got about 10 minutes left. So I want to move on to the next sections. But if you have any questions while you're going through the code as to what a specific word means, you can go back to the definitions, look it up, and you should be able to find an answer. Article 105, application of safety-related work practices and procedures. 105.1, scope. Again, the scope. It's letting us know what this is covering. Chapter 1 covers electrical safety related work practices and procedures for employees who are exposed to an electrical hazard in workplaces covered in the scope of this standard. 150.2, the purpose. These practices and procedures are intended to provide for employee safety relative to electrical hazards in the workplace. 105.3, responsibility. Both employers and employees have responsibilities. The employer shall have the following responsibilities: establish, document, and implement the safety-related work practices and procedures required by this standard. Number 2, provide employees with training in the employer's safety-related work practices and procedures. Those are the employer's requirements. Employee, you also have a responsibility. The employee shall comply with the safety-related work practices and procedures provided by the employer. We've all heard it. Everybody is a safety officer. Our employers establish these rules and we need to follow them. Hopefully, the employers have looked at NFPA 70E, or they have found some sort of training resource that they can provide to you as an employee, that you can take the course, whatever it is that they want you to do, take the course, learn the material, make sure that you go home at the end of every day to go see your families, or if you're single, just go home. Make sure you go home at the end of the day. We want to work safe. We want to make sure that we're making it home and that we can show up the next day and don't have to deal with any type of issues as far as electrical safety is concerned. 105.5, organization. Chapter 1 of this standard is divided into 5 articles. Article 100 provides definitions for terms used in one or more of the chapters of this document. Article 105 provides for application of safety-related work practices and procedures. Article 110 provides general requirements for electrical safety-related work practices and procedures. Article 120 provides requirements for establishing an electrically safe work condition. Article 130 provides requirements for work involving electrical hazards. That's what's in this article. Let's go back. Next section, 110. General requirements for electrical safety-related work practices. 110.1, priority. Hazard elimination shall be the first priority in the implementation of safety-related work practices. That is what we're here for. That is what this book is for, to eliminate hazards, and that needs to be the first priority of every single one of us, whether you're an employee or an employer. 110.2, general. Electrical conductors and circuit parts shall not be considered to be in an electrically safe work condition until all of the requirements of Article 120 have been met. Safe work practices applicable to the circuit voltage and energy level shall be, again, look at that, shall be used. That's what we're talking about. This is mandatory. Safe work practices applicable to the circuit voltage and energy level shall be used in accordance with Article 110 and 130 until such time that electrical conductors and circuit parts are in an electrically safe working condition. That could be that they are locked out and tagged out, right? That could be that they're completely demoed out. Whatever it is, we need to follow what this is saying in both articles, all three, articles 120, 110, and 130. 110.3, electrically safe work condition. Energized electrical conductors and circuit parts operating at voltages equal to or greater than 50 volts shall be put into an electrically safe work condition before an employee performs work if any of the following conditions exist. The employee is within the limited approach boundary. And number two, the employee interacts with equipment where conductors or circuit parts are not exposed, but an increased likelihood of injury from an exposure to an arc flash hazard exists. Electrically safe work condition. Energized work. Additional hazards or increased risk. Energized work shall be permitted where the employer can demonstrate that de-energizing introduces additional hazards or increased risk. Sometimes turning the power off causes more hazards than leaving it on. That's what this is saying. That is when we have to put a hot suit on. That is when we have to create a MOP, a method of procedure, some way, sit down, have a meeting. I've worked on live gear. We were installing a big LI switch. It's a big disconnect basically for high voltage. And we could not shut off that building. It was a government facility. It was classified information in there. They had a lot of stuff going on. We could not shut that off. So we had to tap that bus hot. And it's a scary thing to do. We sat down, we discussed the entire thing. We worked through the entire MOP, came up with that procedure, and executed it. And everybody was safe. Everything was good to go. There's obviously costs involved in that, but hopefully you employers are able in your estimating to assess those issues and put a price in there for that. B, infeasibility. Energized electrical work shall be permitted where the employer can demonstrate that the task to be performed is infeasible in a de-energized state due to equipment design or operational limitations. This is what I was talking about before. We're in some facilities. They have live experiments going on. Some of these experiments go for 5 years at a time, and we cannot shut the power off. So we have to do that work hot. Again, come up with an MOP, create safe work practices, get the right environment, follow the guidelines, and work safely. C, equipment operating at less than 50 volts. Energized electrical conductors and circuit parts that operate at less than 50 volts shall not be required to be de-energized where the capacity of the source and any overcurrent protection between the energy source and the worker are considered, and it is determined that there will be no increased exposure to electrical burns or to explosion due to electric arcs. So we see that less than 50 volts, as long as we follow the parameters, we can do energized electrical work on that. But don't let that fool you. You can still blow fuses. You can still incur cost because you put the wires together. We can set off fire alarms. We can do all that stuff. So you still need to be cautious when you're working on those systems. And most importantly, understand what you're working on. In our office, we were installing one of those Nest thermostat things. And the PMs in there were trying to do it. And I was in there watching them. And they actually tied all the wires in and ended up blowing a fuse because they didn't read the instructions. They didn't know how to install it. And it said right in the instructions that they needed to just take a jumper out of the Nest thermostat if it was a certain installation. And that's actually what it was. So it ended up blowing that fuse. I think it cost them 12 hours of getting a low voltage service guy out there. They had to find the fuse. It was not a normal fuse that you can just order. They just didn't know what they were doing. So understand what you're installing. That's really key number one to be safe, is understand what's going on. Next, normal operating condition, D. Normal operation of electric equipment shall be permitted where a normal operating condition exists. A normal operating condition exists when all of the following conditions are satisfied. The equipment is properly installed. The equipment is properly maintained. The equipment is used in accordance with instructions included in the listing and labeling and in accordance with the manufacturer's instructions. The equipment doors are closed and secured, and all equipment covers are in place and secured. There is no evidence of impeding failure. And the last section that we'll be able to cover today, again, I'm going to try and, as I create more courses throughout the next couple of years, go through the rest of these videos so you guys will have them. But again, I just want to reassure you, you can take the course year over year. I provide updates to the course. You just can't get credit for the same course twice in 1 year. Not that you would try and do that, but that's what it's there for. So 110.5 electrical safety program. A general, the employer shall implement and document an overall electrical safety program that directs activity appropriate to the risk associated with electrical hazards. That is all we got for this video. Again, we got 2 more. You're almost there. There's going to be 2 more attendance verification questions. Super simple. Answer those real quick, and let's go on to the next one.